Okay, electrolysis of aqueous copper 2 sulfate using a copper electrode. Okay, so you know that you should know that copper electrode they are reactive. So the Cu2 plus and Cu on both sides of the electrode they are going to react. So in the case of the anode, what is the reaction that's taking place there? I hope you say it's oxidation. So we can either choose between Cu2 plus or Cu. So which one will get oxidized? Hope you say Cu. So the Cu anode will get oxidized to become Cu2 plus. And when that happens, the Cu would gradually dissolve into the electrolyte and the mass will decrease. Okay, so immediately you should cross out A and C. Now the next thing is we have a steady current here. So we would expect the mass decrease to be occurring at a constant rate. So it's a constant rate of decrease. Yeah, so the option should be B. Now for those of you who choose D, let me tell you why it is wrong. If you look at the gradient of the curve over here, the mass time curve, the gradient will give you the change of mass per unit time. Now, since the gradient is not constant, therefore it means that the change in mass is also not constant. But this can't be happening because the flow of electron is steady because of the steady current. So it can't be D, okay, because of the steady current. Yeah, so option B. Okay, we are trying to determine the order of reactivity of the three metals over here based on a few reactions over here. Okay, so we look at the first one. T2 plus existing as an ion, you put in a metal V and there is no reaction. Now, whenever we put in a more reactive metal into a less reactive metal ion solution, there should be a displacement. But if there is no displacement, we will know that V is less reactive than T, since there's no displacement. Yeah. Okay. Now we look at the second one over here. 2V plus U, and you have a reaction. Now, only a more reactive metal can displace the less reactive metal ion. Now, if you know this, you will know that U is more reactive than V. So U is more reactive than V. And we look at the last one over here. You add metal T to U, you get a displacement. So what is more reactive, T or U? Yeah, only a more reactive metal can displace the ion of a less reactive metal. So T will be more reactive than U. Okay, so you can see that okay, now T should be the most reactive then, right? So because T is more reactive than U, and from this statement, T is also more reactive than V, and U is more reactive than U. So T is the most reactive. Yeah, so this is the most reactive. We got to choose between U and V now. So U is more reactive than V. So I will put U here and V here. So this is the least reactive. Yeah, so that is option B. Which solutions would produce hydrogen after electrolysis using platinum electrodes? So platinum is an inert electrode. So when you consider the different solutions, you got to consider the different ions present in the solution. In concentrated hydrochloric acid, we have H+, Cl-, and OH-. So the H+ will get discharged definitely. So yeah, so this will get discharged because this is the only positive ion around. Yeah. And for aqueous sodium chloride, we have H plus, OH minus, Cl minus, and Na plus. So you got to compare between H plus and Na plus. So which one is the one that's going to get discharged? So Na is so reactive, it can't get discharged, so it's out. So we will get H plus to get discharged. Okay, so H plus, yep, discharge, discharge. Dilute sulfuric acid, you have H plus, OH minus, SO4 2 minus. Yes, so H plus is the only positive ion, so it's going to get discharged. Okay, so all three options are correct. We look at question 19. Let me just show it down a bit. Question 19. Which statements regarding the following reactions is or are correct? We got to determine the oxidation number for iodine and chlorine when we tackle this question. So in IO3 minus, iodine will have an oxidation number of +5 because +5 -6 because the -6 is from the 3 oxygen, each one having a -2 oxidation state, will give you a -1. So iodine here is a +5. It's a +5 here. Okay, so the oxidation number of iodine in IO3 minus changes from +5 to +1. Yeah, which is true. Yeah, +5 here goes to become +1 here. Why is iodine in the product +1? The reason being, iodine is less electronegative compared to chlorine, so you will got to take on a oxidation number of +1. So 1 is correct. Statement 1 is correct. Oxidation number of iodine in I minus changes from -1 to +2. Okay, the -1 is correct. Iodine here is -1, but after the reaction, it has a oxidation number of +1, not +2. Yeah, so this is wrong. Yeah, 2 is wrong. Number 3, the oxidation number of chlorine before and after the reaction is different. No, it's the same. So over here is a -1. Over here, it is still a -1. Yeah, so this is wrong. This is same. Let's look at the last question, the last MCQ question. Electroplating is a process in which metal ions in a solution is moved to coat an electrode. We are asked to determine the correct statement. So the mass of metal deposited in a fixed period can be increased by using a larger current. Yeah, this is true because a current, they are moving electrons. So the faster you move electrons through the whole system, the faster you can increase, the quicker is the deposit of metal, because a reduction of metal requires electron to flow through. Yeah, so number 1 is definitely correct. Assuming a constant current, which means that the rate of flow of electron is the same, increasing the concentration of the metal solution will increase the rate of electrolysis. No, and the rate at which electrolysis will take place will only depend on the current, and also only the current. Yeah, so increasing the concentration will not have an effect if you assume that there is a constant current. If you want the electrolysis to be for plating, you want to place the plate at the anode of the setup. So the anode is where the oxidation will take place. But if you want something to be plated, you want the ion to get converted into a metal. Yeah, and for a metal ion, this process is a reduction. So this is a reduction, but this is an oxidation. So again, option 3 is wrong. Oh, I'm sorry. Here I got this wrong. It's a wrong statement. We are asked to look at a few statements regarding electroplating. So let's look at statement 1. The mass of metal deposited in a fixed period can be increased by using a larger current. This is a true statement because a moving current, they're actually moving electrons. So the faster you can move electrons through the entire system, the faster you can change whatever metal that you have here from Mx plus to become M. Yeah, so this is a reduction. So the faster you can flow electron through here, because this requires electron. Yeah, so this is a correct statement. Assuming a constant current, increasing the concentration of the metal solution will increase the rate of electrolysis. Over here it says that a constant current. So a constant current means that the flow of electrons is the same. So even if you increase the concentration, it is not going to increase the rate of electrolysis or the rate of electroplating. The rate of electroplating can only be increased if you use a larger current. Okay, or only if the current is affected. Yeah, so number 2 is wrong. The item can be placed at the anode of the setup. So the anode is where oxidation will take place. Item to be plated. So if you want something to be plated, Mx plus will become M, right? And you need to add in some electrons. And I hope that you know that this reaction is a reduction. So this is a reduction, but oxidation takes place at the anode. So this is a false statement. So that concludes the section on MCQ.